Okay, so the price P of an item at time t years is to be modelled as a continuous variable such that the rate of increase of P is directly proportional to P. So when we write down the differential equation, we need to appreciate that the rate of increase of P, okay, so dP by dt, so how P changes with respect to time, okay, so that's what those words mean there, yeah, the rate of increase of P, or the rate of how, and you mentioned the word rate, is how P changes, okay, with respect to time. So dP by dt, and it's an increase, so it's positive. It says it's directly proportional, okay. So that's word is important as well, directly proportional to P, okay. So positive there because it's a positive gradient, yeah. So it's increasing gradient because it's rate of increase. So now that will be helping us to start to get part A, but we haven't got the differential equation yet because we've got this alpha symbol here. So to get the differential equation, we need to then introduce a constant k, and then our letter p then multiply by it. So we can say that equal to this constant k times p. Part B then is given that the price of the item at t equals 0 is £50, show that p equals 50e to the kt, okay, where k is a positive constant. So what I'm going to do here now, I'm going to separate the variables. Okay, so I'll have dP by P will equal to K dt. So we'll have integrals both sides. So taking the P down, dt up. So then, integral of this then, well, this will be ln P, okay? Because it's like 1 over P, yeah? It's 1 over P dP, so that becomes ln P. K then, integral, well, K is a constant, so with respect to time then will be T, and then plus then your constant C. Okay, now we're told when t is 0, the price is £50. Okay, so when t is 0, p is equal to 50. So that means then ln 50, because that's what p is, t is 0, so you get your constant. Be ln 50. Now keep it as ln 50. Okay, don't work that out. Sub it into here. And then you can rearrange this, right, in order to get what they want. So take the ln 50 over. So 2 logs taken away, using the laws of logs then, you divide the terms. And then, because there's an ln, we can take the ln over the other side, and it becomes an e. So e to the kt, we just get p over 50 there, and we can take then the 50 up. We've got p equals 50e to the kt, okay? So then it says part C, after 7 years the price is £65. Find the price of the item after 16 years. So what you can do then is when t equals 7, the price will be 50 e to the 7, that's what t is, isn't it, k, but we know the price will be, what do they say, £65, so we can have that there. Okay, so then we can take the 50 over, because e to the 7k, and then we can take the e over. So when you take the e over, remember when you take the e over, you do the opposite. The opposite, and the opposite of e is ln. Okay, always do the opposite when you take it over, and the opposite function of e, the inverse of it, is ln. So then you've got that, you've ln that side, and then take the 7 over. So k will be ln 65 over 60 divided by 7, and you can get your answer out. So if you use a calculator on that, so with k then we want to get a value out, so so I get k to be 0.0011, no, there's only 1 0 there. Oh, let me write that again. So 0.011435, okay? So that's my value of k. So then prime the price after 16 years. So if we then take this formula, when t is 16, the price will be 50 e to the 7, not 7, 16, sorry. So take that formula here. 16 times 0.011435, so p will equal to 60. Okay. That's what I got out. £60.